Okay, so now we need to define what is a desert. So a desert is going to be an area that supports vegetation on less than 15% of its surface, and deserts tend to receive less than 25 centimeters of rain each year. So 25 centimeters is, roughly about that much. And so, for example, at the North Pole, you'd think it snows a lot up there, but actually it doesn't. So the North and the South Poles are actually deserts if you use this definition of moisture. Deserts tend to cover about 20% of the Earth's surface. So if you will look at this picture here in yellow, it shows where the major deserts are located at on Earth. So what are some different types of deserts? So the first one is a subtropical desert. An example of this would be the Sahara Desert. So in a previous episode, we talked about climate. And we said that when air can rise, that will allow moisture to rise, and then it will form clouds. So this would be under a low pressure system. Under a high pressure system, the air is being pushed down, and that basically does not allow clouds to form. So under a high pressure system, no clouds. Under a low pressure system, it tends to be cloudy. So then the next question is, where would these things occur? So we talked about the Earth, and the Earth has an equator, which is going to be very hot. So air is naturally going to rise at the equator. It's also very cold at the North Pole, so air is going to tend to fall at the North Pole. And so if the Earth was not rotating, then there would just be one convection cell in the northern hemisphere, and there'd be one convection cell in the southern hemisphere. But because the Earth is rotating, that causes a Coriolis force that tends to bend wind systems to the right. So as this air is trying to go north, it's also being bent to the right, and eventually, by the time it reaches 30 degrees latitude, so let's put that over here. So at 30 degrees latitude, it has bent as much as it can, and so it has to return back to the equator. So the air will come back down, and then it returns to the equator. So that is one of the convection cells. There's also another convection cell that is going to go up to 60 degrees latitude, and it is going to be a convection cell in the opposite direction. So air is going to be coming down here, and then it goes north, and then it's actually going up at 60 degrees latitude. And then there's one more convection cell that's going to be up here, and at this one the air is going up, and so at 30 degrees latitude, so right here at 30 degrees latitude, air is going to be coming down. Air is coming down. So that means no cloud formation. So you're going to have major bands of deserts at 30 degrees latitude. Now right here though, air is going up, so you will have clouds located right here, and you will have clouds located at the equator. So this is one reason why deserts tend to form. It has to do with the global wind systems and areas of natural high pressure and low pressure. So if you were to start in the 30 degrees latitude, corresponds to approximately the United States-Mexico border. And you know it's very dry there in New Mexico and Arizona. Okay, if you carry that across the United States and then across the Atlantic Ocean, then you get to the Sahara Desert. So deserts tend to occur at about 30 degrees latitude. Okay, another type of desert is a rain shadow desert. An example of this is going to be Death Valley. So that if you have a mountain, and then let's say you've got moist air that is traveling this way. So as that moist air climbs, it's going to start to get cooler, and it's going to start to condense into clouds, and it's going to start to rain. So on this side of the mountain, you're going to have rainfall. But by the time it gets up to here, it's lost all of its moisture. So that by the time it's down on this side, it's very dry. And so that's going to be a rain shadow. An example of this is going to be Death Valley. Okay, another one is called a coastal deserts. And so you have these off the coast of Peru, for example. So what's going to be happening here is, let's draw a little picture of South America. And then you've got, because of the convection in the oceans, you've got cold water from the poles down here is coming this way, and it's trying to get up here to the equator. So you've got cold water, surface water, up against the coast of Peru. So what that does is it's going to draw heat out of the air above the water. So you got the surface of the water, which is very cold. It's going to pull heat out of the air above it. And one of the things that you need in order to have a cloud is moist, warm air. So the warm air is going to rise, and then it makes a cloud. But if it's cold air, it can't rise as much. And so you're not going to have as much cloud formation in cold conditions. And so then that means that the air that is going to be flowing onto Peru is going to be very, very dry. And so you're going to tend to have deserts in places like this. Okay, another one is a continental interior desert. An example of this is the Gobi Desert. So after traveling a long distance across a continent, air masses lose their moisture. So the further a moist air mass travels, the more it's going to rain. And eventually it's going to run out of moisture, and so it's just going to be dry winds that are going to be blowing across the continent, and an example of this is the Gobi Desert. Polar deserts. So we mentioned up here that the air is coming down at the North Pole, and when air comes down, it doesn't allow clouds to form, and so high pressure systems exist at the poles, and the cold air cannot hold much moisture. So that actually Antarctica is considered to be a desert. All right, let's take a break. When we come back, we're going to talk about what controls the development of desert landforms.